All right, here we go. So, derivative of both sides. Oh, first, little side quiz. I want everyone to answer this. This says ln, but I'm going to use something that's a bit more commonly misunderstood. I want to know, is this the same as this one? Or is it the same as this one? Or is it the same as this one? Hands up. Is this item in pink the same as the green, the blue, or the red? This is a really common mistake that this kind of reminded me of. Is this item in pink the same as the green, the blue, or the red? Michaela?
Is it the green?
So Michaela votes green. How many vote with Michaela? Sweet. Point, 2 for Michaela. Everybody okay with that? Awesome. Yeah, that's correct. Now, the other one I want to make sure you notice is right here. So this is not the same as that, so let's erase these. But you will not ever see on an AP test something like this. At least I never have. Okay, you'll never see this. You always see it written in a different way. You'll see it written like this. So you have to memorize that this is what you will see. But it means this. You cannot make that error. Like I've seen people on a test, literally, that's the only reason they missed the test question, is because they just forgot that this means this. And then they're messed up. Okay, want to talk more here?
So the exponent's that.
So this one, Sarah, 2 points for asking. This does not have a good reason. So I tell you a silly story. Here's the story. Some guy, I don't know the truth, but this sounds good to me. Some guy wrote like this for his whole life. And after 40 years of writing the 2 parentheses and the fifth, which makes perfect sense to all of you. Does everyone understand this one? He had this great idea. He's like, hey, I want to be like somebody who knows something no one else knows. So I'm going to stop writing it like this and write it like this so everyone will be confused. But somehow he convinced all the other mathematicians, like, hey, yeah, let's make it confusing for everybody. So we're going to write it like this. It's just because it's, I don't know. Is that okay? Anybody else? Awesome. So don't forget that. Okay, back up here. This is kind of similar. Hands up. Points for everybody. What is being raised to the 5th power up here? Hands. What is being raised to the 5th power? Let's go Koji. How many agree? Point 2 for Koji. So I take the derivative of both sides. Any questions about the fact that we use the ln rule first? Do you need me to explain that? So memorizing the ln rule is really easy. Derivative of ln of something is 1 over the something. You don't have to memorize the second half of the rule, because the second half of the rule is always the same. Now I find the derivative of that something. because the rules always work their way from the outside in. So the ln rule took care of the ln portion. Now we have to worry about the stuff that was inside the ln. So the rule is easily memorized. Derivative of the ln of something is 1 over the something multiplied by derivative of the something. Question? Cool. Next line. I like to combine the, and you're fine to do this now if you'd like. I'm going to use the constant, multiplying constant rule. So this is multiplied by this, but when I pull out the 4 now is multiplied. I'm just left with the derivative of x to the 5th. So that was the multiplying constant rule. Please.
What happened to the natural log when you did that one?
So come over here. We started with this, right?
Yeah.
So we got d dx, ln of g.
Okay.
So what's g?
Yeah.
Perfect.
Yeah, okay.
That's it now. Good work.
Okay.
Right? Anybody else? So next line. I didn't combine them. I guess I thought to, and then I just didn't. So. Ashley, another point, correctly indicated this is in the numerator. And we have 5, so we're going to multiply here. Question? Please.
So I forgot on the power why we can multiply it if it's just the x, and if we take out the constant, why we can multiply,
Multiply what?
if we use on D on the green, on the dx5.
So-
why we can use down the power.
Let's just talk through it. So do you see that this d is this d?
Yeah.
Dx dx, you there? So what's g of x?
G of x.
It's probably easier if you start with n. What's n?
Oh, n is 5.
Good. G of x is simply whatever is being raised to the 5th. So what's g of x?
That's 3 bucks being raised to the 5th. Is that 4?
No. So in the power rule, the g of x is whatever is being raised to the power.
Oh, okay.
So right here, we want to use the power rule. So what is the power,
5.
and what is being raised to that power?
Oh, 5. X.
So say it again. What is the power,
X. Okay, the power is 5 and it's being raised.
and what is being raised to 5?
X.
Just x.
Yeah, okay.
So up here in the rule, that means this is 5, this is x. So when I apply the rule, this is 5, this is x, this becomes 4,
Okay.
d of x.
Yeah.
I'm not sure if that helped.
No.
You good? Okay, 2 points. Anybody else? Okay, this is 1. Hands up. Who can name the factors of the numerator? Name the factors of the numerator. Let's go, Sarah.
Is it just 4 and 5x?
So break it up into smaller pieces.
Or 4, 5, and x?
Very good. Yeah, it's important you notice that these aren't really together. We say it all the time, 5x to the 4th. We always mean 5 multiplied by x to the 4th. Yeah. How many saw it? Point, 2 for Sarah. The factors of the denominator are 4 and x to the 5th. Because numerator is factored and so is denominator, I can legally divide factors. So this 4 can divide with this 4. X to the 4th can divide with x to the 5th. We're left with an x on the bottom and a 5 on the top. They want to talk more about it? Homework is 1 through 20. Answers are in the back, on the back side. And as you saw, there are lots of videos. If you, for some reason, get stuck, you can just find the right video to help you with the homework. So, if not, you can come talk to me, but I hope the videos are helpful. So, good work. Bell ring in 45 seconds.